Hello, this is Brandon Weekly with Microchip, and in this video we're going to be covering how to enable key revocation for the CEC1736 Platform Root of Trust controller in our Trust Platform Design Suite software. To fully grasp the value of the security that's being added to your system by key revocation, you'll want to have a basic understanding of asymmetric cryptography. If that's a completely new concept to you, we recommend checking out the Cryptography Primer Microchip University course, which will be linked in the description. But the absolute basics are that we have public keys and we have private keys. And the private keys are used to sign your code images before they're deployed into the field. And the public key is used in the field to verify whether or not the legitimate private key was used. The whole crux of the security here is that they can verify each other, but they cannot be used to mathematically reverse engineer each other. They're related, but you cannot derive one from the other. Now, during every stage of your development, you want to make sure that your private keys remain completely secret, that nobody other than the entity that manages them, whether it be you, whether it be Microchip, can actually access them or ever see them. Now, the idea of key revocation is to cover the base of what happens if for some reason one of the private keys actually gets out, if it gets compromised. Well, you have several private public key pairs that are provisioned to you with every CEC1736 that you have. And again, if your private key gets compromised, we can simply rotate to another key. And you can do this up to 32 times for the CEC1736. Ideally, it's going to be 0, of course. But this is an extra barrier of security that if, again, your private key gets leaked out, if for some reason it gets compromised or cracked in some way, we can simply rotate to another pair and your fleet of devices or platforms, whatever you have in the field, remains secure with a simple firmware update that tells it to rotate to that next set of keys. Here in Trust Platform Design Suite, key revocation is one of those features that's very simple to enable, given that you don't have to configure much. You just select whether to enable it, and we'll select from one of two different modes. So to do that, again, we're starting from our home page in Trust Platform Design Suite. We navigate over to Configurators and select the CEC1736 configurator. That'll bring up a screen that looks like this. And you want to navigate over to System Configuration, scroll down, and ensure that key revocation is selected. If it is selected, you'll see it appear over here on the left-hand side, so we'll click there. And if you want some more details about what is going on in this feature, you can take a look at this transaction diagram here. So the transaction diagram is split into two sections. We have the provisioning and the prototyping side, and then runtime, where the actual implementation of key revocation may actually occur in the field. So provisioning and prototyping, we have our setup information for key revocation. That's what you're doing here in Trust Platform Design Suite. Before you generate your provisioning package, you're simply selecting whether or not you want to use it. You see here that we have auto versus manual key revocation. Those are the two different modes that we have to select from. And then for provisioning, just like any other feature of this part, we program the one-time programmable block. We program the internal SPI and the external SPIs. Now for runtime, if you've seen the Secure Boot video or explored that feature, this will look somewhat familiar. But the first thing that we do is verify the root of trust, that being the EC firmware code or the Soteria code. If that's verified, we then check on the entire chain of trust, which consists of the key hash blob, the AP config tables, and the hash tables, as well as the application processor images, which are what are stored in the external SPI flash. And what you see here is just a simplified version of what happens during Secure Boot when we check on those images. Now for the actual key revocation side. As I mentioned, we have two different options we can select from. One is auto key revocation, and the second is manual key revocation. With auto key revocation, the key revocation is something that's done by the embedded controller. It's done by the CEC1736. With manual key revocation, it's a command that you can send from the application processor to the CEC to then tell it to rotate to another pair of keys and revoke the access of the previous pair. And once we are past that step, we consider the chain of trust to be enabled. So relatively simple transaction diagram there. And also a relatively simple feature to configure, as I mentioned, because we either have it disabled, we have our auto key revocation, as I explained, or the manual key revocation that we can select. So do you want it to be managed by the embedded controller, the CEC, or do you want it to be managed by your application processor? Also to note, as we've mentioned on other features before, this is an OTP parameter, which means that for one particular CEC chip, you can only select this feature one time, and then it's permanently programmed into that chip. If you're working on a provisioning package and you program a CEC with this feature and you want to try a different setup, you'll need to swap out the chip and try a different configuration. Thank you for watching this video on key revocation with the CEC1736 platform root of trust controller. To learn more about this part family, check out the links in the description. And to learn more about the other security solutions offered by Microchip that can strengthen your designs, check out the other videos in the Chiptorial playlist. Thank you.